Hi, good afternoon. This is chapter 3, question 21, the dynamics tutorial. So here we go. Okay, let's look at this question. Now, if you look at this question on my screen here, you can see some of the numbers being colored. So when you read a question, you can see better if you annotate key information, key data such as the mass, the velocity, and crucial clues such as the road being horizontal. Things like this, if you underline it, it will help you bring to light and see the vital data more clearly, and that will perhaps reduce your chances of making careless mistake. So a car of mass 750 kilograms traveling at 25 meters per second along a horizontal road. The brakes are applied and the car is brought to rest by an average resistive force F. The car has an average deceleration of 4.8 meters per second square. So we step on the brake and the car slows down till eventually reach zero. So the first part show that the resistive force acting on the car is 3,600 Newton. So show, I hope you all know the meaning of show. Show means you have to write down the formula and then the substitution. That is how we score the mark for show. So F equals to MA and show the substitution. The mass is 750 and the deceleration is 4.8. So that is how you get 3,600 newtons. So the marks, this 1 mark goes to equation and substitution. Okay, it doesn't go to the 3,600 at all. Okay, so hope you all know what's the meaning of show. Now, calculate the distance traveled by the car during the deceleration. So remember, it decelerates to rest. So this is a kinematics question. So kinematics question, you choose one of the three equations of motion. So what you have is velocity, you have the deceleration, and they want you to find the distance traveled, or since it's one horizontal road, is the displacement. So with that, you can only choose equation, the equation that says v square equals to u square plus 2as. So the final velocity 0, initial velocity 25. So plus 2. The deceleration is 4.8, which means an acceleration of negative 4.8 multiplied by the displacement. So the displacement is 65.1 meters. Okay, so 2 marks, equation, substitution, and 1 mark for the correct answer. How many SFs do you put your answer to? Well, look at the numbers that you put. 4.8 is 2SF, 25 is 2SF. So your final answer must be 2SF or 3SF only. If you give your answer to 1 or 4SF, you will have 1 mark deducted. Okay, so third question. Describe in terms of Newton's third law the horizontal forces acting on the tires of the car and on the road. Okay, the forces acting on the tire and the forces acting on the road. Now remember Newton's third law, what do they want you to show? Whenever it's a question of Newton's third law, they want you to show this: the force that A acting on B is equal and opposite to the force that B acts on A. So it is two bodies, body A and body B, and then the force is equal in magnitude and opposite in direction. So when you use Newton's third law to write down an answer, identify the two objects first. So in this case, the question have told you what the objects are. It is the tire and it is the road. Okay, so it will be easier this way if you write it like that. Okay, tire and tire, road and road. Okay, so plan out your answer. So with that, draw it out. Okay, now this is the road and this is a tire. So let's say let's say the car. Okay, the car is moving to the right. Okay, direction of car. So since it's moving to the right and it is decelerating, it means that the force exerted on the tire, which is the car, is in the opposite direction. Okay, so this is the uh, force that is uh, wrote on tire. Okay, and with that, the equal and opposite force, that is the action reaction pair, will therefore be T on R. So the tire on road, okay, the tire on road, T tire on road will therefore be forward. Okay, so this is how you plan your answer, and after that you write it out, so you will not get it wrong this way. Okay, so 2 marks, 1 mark for road on tire, the other mark for tire on road. Okay, so remember, for qualitative question in physics, you have to plan your answer first. Plan it. Newton's third law is A on B, B on A. Ask yourself, what is the A, what is the B? Okay, plan it out, and then maybe help you see better by drawing a diagram. And then after this planning, you write down the answers in words. So the force of the road on tire, because the tire is part of the car, it has to be opposite direction of motion. So the direction of the horizontal force is opposite in direction to the car's motion, since it's decelerating, and therefore the action reaction will be the other direction. The force of the tires on the road, okay, is the same direction as the car, since the force an action reaction pair with this one. Okay, so plan your answer, then you write it out for qualitative question. Now the next one, what do we have here? So just now the car travels on a horizontal road, 25 meters per second, same as just now. But just now was horizontal, but now it is not horizontal. Now it is 10 degrees to the horizontal. The resistive force is still 3,600. Why the distance the car travels before coming to rest is greater than that of A? Okay, there's only 1 mark. So 1 mark, you just need to put 1 point. Remember, a diagram paints 100 words. So let's draw the diagram. Although this is more than 10 degrees, but never mind, we just draw it out. So this is the same car, and the force acting on it is mg, and there is a resistive force of 3,600 newtons. Okay, so just now the resistive force, just now when you step on the brake, the net braking force, okay, is simply 3,600, but now it is not 3,600. Okay, now the net braking force is actually 3,600 newtons minus mg sine 10 degrees. Okay, so this means that the net deceleration has now decreased. So if the net deceleration is now decreased, if you go back to the v square equals to u square plus 2as, although a is negative formula, you'll find that the s is a larger number than that of part A. Okay, so but since it's only 1 mark, all you need to say is that the net deceleration is now less than 4.8 meters per second, and the net deceleration equals to 3,600 minus mg sine 10 divided by the mass, okay, which is smaller than the 4.8 meters per second square. So what about the deceleration? So let's calculate it. So F equals to ma. Okay, so the net force is now 3,600 minus mg sine 10 degrees equals to ma. So after doing all the relevant substitution where m is 750, you'll find that a is equals to 3.1 meters per second square, which is smaller than the 4.8 meters per second square if it was on a horizontal road. Okay, so this is the explanation for question 21, and the full write out of the solution is here. Thank you very much.